Welcome to Lesson 4 of Migration Mastery. The translation table now deeper. The verb map from Lesson 2 got you through the common cases. This deck is the complete reference, 30-plus paste-ready patterns organized into 6 categories: tables and chains, match conditions, conntrack, NAT, ipset-to-sets refactors, and jumps with logging. Bookmark it. You'll come back to it every time you translate a real rule set. The deck climbs through 4 levels of translation depth. First, structural patterns, the tables, chains, hooks, and priorities that iptables kept implicit and NFT forces you to declare. That's where most day 1 mistakes happen. Second, match conditions, where the token order flips and you have to retrain your fingers. Third, action translations, mostly one-to-one, except DNAT and SNAT, which carry chain priority semantics that will bite. And fourth, the multi-rule refactors, collapsing 50 IPset references into one named set, rule piles into verdict maps. That last level is the actual reason you're migrating. So we start with the plumbing, because in NFT, nothing is implicit. You declare the table, you declare the base chain with its hook and priority, and only then do rules have somewhere to land. Skip this, and NFT add rule returns no such file or directory, which trips up everyone on day 1. Note 2 structural shifts worth burning in. Default policy moves into the chain declaration itself, and user chains are just chains without a hook, reached via jump. And when you need a clean slate, NFT flush rule set is the one-liner equivalent of iptables-f, except it actually wipes everything. With the plumbing in place, matches are mostly a syntax swap. The kernel's doing identical packet inspection, you're just spelling it differently. Flags become positional tokens, S becomes ipsatter, D becomes ipdatter, and edport becomes TCP dport. 2 upgrades worth calling out. Port ranges use a dash instead of a colon, and multiport collapses into native set syntax. TCP dport is 80.443. No AM multiport extension required. And for IPv6, you switch the family prefix to ip6 sadder, which is cleaner than juggling separate ip6 tables binaries. State matching is where the syntax swap really pays off. The magic rule you've typed 10,000 times, conntrack, seat state established related j accept, collapses to ct state established related accept. Same kernel module, same conntrack table, just lowercase tokens and no extension loading. The pattern holds across the board. CT mark replaces con mark, and helpers attach with CT helper set instead of the awkward JCT helper target. If you internalize one prefix today, make it CT. It's the gateway to every stateful expression nftables exposes. NAT is where most migrations quietly break, and it's almost never the rule itself. It's the chain. In nftables, your NAT-based chains must declare the right priorities. DNAT at -100 for pre-routing, SRCNAT at 100 for post-routing. Get those wrong or forget them entirely, and your DNAT and SNAT rules load cleanly, match cleanly, and do absolutely nothing. Packets sail past the hook. Once the plumbing is right, the translations themselves are mechanical. DNAT2 for redirects, SNAT2 for fixed source rewrites, and a bare MASQUERADE when you want the interface's current address. Declare the chains first, always. From plumbing to payoff. Sets are where nftables stops being a syntax change and starts being an actual upgrade. IPset was always a bolt-on. Separate binary, separate syntax, separate save and restore dance, and a nasty race window during reload. Native sets fix all of that, declared in the rule set, updated atomically, referenced with a simple @ sign. And you get things IPset hash types literally cannot do. Interval sets holding CIDR ranges directly, and dynamic sets populated by meters, so a misbehaving SSH client rate limits itself into a block list with no user space glue. Bookmark this one. Now the connective tissue, control flow, and observability. Jump and return map cleanly. J my chain becomes jump my chain, J return becomes return. Logging gets a real upgrade though. nftables lets you compound actions on a single line, so log prefix X. Drop replaces the old two-rule log then drop pattern that always risked drift. On the right, rate limiting. The simple case is a near-direct swap, but hash limit, the per-source limiter you've been cargo culting for years, collapses into a meter with an inline limit expression. Cleaner, faster, and the state lives in the rule set. And here it all is. Every translation we've walked through condensed onto a single page. Structure and match on the left, stateful and NAT in the middle, sets and actions on the right. I'm serious about printing it. The muscle memory comes around Rule 50, and until then, this card saves you from context, switching to a man page every 2 minutes. Bookmark this slide. It's the one you'll come back to. Reading isn't enough. You need the syntax in your fingers. So here are 3 exercises, escalating in scope. Start with a full input chain rewrite, 20 minutes. Just remember the table and chain declaration with hook and priority, or your rules route nowhere. Then port forwarding, DNAT plus MASQUERADE, and watch those priority DSTNAT and SRCNAT keywords. Priority 0 is the classic mistake. Finally, take a real IPset off one of your servers and convert it to a native set with a set name references. Expect a 30 to 40% line count drop. Run them on a throwaway VM, verify with NFT list rule set, and you're done. Now, before you ship any of that, here are the 5 mistakes that will pass code review and bite you in production. Wrong NAT chain priority. Priority 0 parses fine but runs in the wrong net filter slot, so DNAT silently bypasses. Always use the named priorities, SNAT and SNAT. Forgetting policy drop in the chain declaration leaves you with an implicit accept, no firewall at all. If stores an interface index at load time, so on VPNs and containers use IIF name. Contract states are lowercase in NFT, established, not established. And the rule never fires if you mix them. And set element types must match how you query them. IPv4 adder sets can't be referenced from IP6 sadder. Each one parses, each one accepts, each one breaks silently. And that's the complete translation reference. 30+ patterns mapped, NAT priorities pinned down, IPset to sets fluent, and the silent traps cataloged. Every iptables construct you're likely to encounter now has a known good nftables form. Bookmark this deck. You'll come back to it mid-migration. Next up, Lesson 05. We put iptables-translate to work, where the autoconverter earns its keep, where it quietly lies to you, and when to just write the rule yourself. See you there.